Okay, today we're in section 9.1, square roots. We're in our textbook on page 453. All right, first thing we need to talk about is some definitions. The first one is the definition of a square root. Please make sure you write this in your notes. A square root is a number, then when multiplied by, here's a key word, itself, equals a specific number. And that is what we know to be a perfect square. Every positive number has two square roots. So how many square roots does it have? Two. Both the positive and the negative version of that number, okay? And I'll show you in a second how we're going to show that. So every number has two square roots. Two square roots. The radical sign is the square root sign. So just write in your notes, radical sign equals, and then draw the radical sign. Okay? And it represents a non-negative square root. So if you see the radical sign, guys, now it's specifically going to be a positive number unless there's a negative attached to the radical. So the radical sign is positive. Does that make sense? The radical sign is positive. All right, and then we use a plus and minus symbol to refer to both square roots of the number. All right, so you probably are better off just by writing every word of those definitions, but those are just some highlights. 0 has only one square root, and that's 0. All right, so let's see what this looks like in an example. All right, they give us a chessboard example. If you're open in your books, you can read along with me. If not, just listen. It says, in September of every even-numbered year, people in, we'll just say Italy, because that's a funny word. Anyway, they play an unusual chess game. Each chess piece is portrayed by a person. The people portraying the knights are even on horseback. So the chessboard is 324 square meters. Basically, they're asking, what is the square root? How long is each side of the chessboard? So what we're going to do is we're going to take the square root of 324. Here's the convenient part. We can use our calculator, okay? So go ahead and get out your calculators. I'll show you where the square root sign is if you haven't found it already. And what is the square root of 324? Okay. Now, if you're unsure of where the square root sign is, it's the button right below x to the third. It's like far left, second row. Second from the left is right next to the fraction button. You just tap that button, enter the number that you're trying to find the square root, and press equals. Now, let me ask you this. Since I am measuring a chessboard, is it possible to have a negative measurement? No. So we have to think about this practically. Since this is a word problem, and it's not possible to have a negative measurement, my only answer is going to be positive 18, and I guess it's meters. Okay, so I would say square root, use my radical, it's positive, of 324 equals 18 meters. And honestly, you can abbreviate too. That would be fine. Here's how it's going to look on your homework. All right, on your homework tonight, it's going to say, find the square roots of the number. Now, in these original problems, do you see a radical sign? No. Now, if you see a radical sign, you'll know whether your answer is positive or negative. But without a radical sign, they're looking for the positive and negative version of that number. Well, we all know what the square root of 16 is. What is it? 4. So I would say positive and negative 4. Because again, my original problem does not specify whether I'm looking for one answer or the other. It wants both. So I show both by using the positive, negative symbol in front of the number. All right, I want you to go ahead and try the other three. Use your calculator if you need to. All right, so what about 64? What's 64 going to be? Just tell me.
8.
Not 8. Positive and negative 8. So don't forget that sign. If you just say 8, that's not correct, okay, because there's two square roots. What is negative 8 times negative 8? Positive 64, okay, so that still works out. That's why each number has two square roots, because a negative multiplied by a negative is going to give us the same number, a positive answer. What about 144? Positive and negative 12. What about 256?
Positive and negative 16.
All right, good job. Any questions? All right, let's look at example 2. Now, in example 2, we have to understand first what it means to have a perfect square. And a perfect square is a number that I can evenly take the square root of. All right, so 4 is a perfect square because what can be multiplied by itself to equal 4?
2.
2. 2 times 2 is 4. 9 is a perfect square because 3 is its square root. 3 times 3 is 9. What's my next perfect square?
6 times 12.
Goes after 9. No.
36.
No. 16. What's 4 times 4? Yep, so 16 is a perfect square. 25, because 5 times 5 is 25. 36, because 6 times 6. 49. Do you see the pattern? 64. 81. Okay, and then it just keeps going. All of those numbers, the product, okay, 4, 9, 16, 25, 36, those are perfect squares. All right, so does everybody understand what a perfect square is? Everybody with me? Okay. So now, are these numbers here, 51, 93, and 24, are they perfect squares? No, they're not. They're not perfect squares. But I can look at that number and I can ask myself, okay, 51 is not a perfect square, but what is the closest perfect square to 51? Okay, I heard it. 49. Okay, so I know that the square root of 49 is going to be a little bit less than the square root of 51. What's the next perfect square above 51? No, perfect square. 64, right? So I know that the square root of 51 is going to be less than the square root of 64. Do you see how we're finding the perfect squares on both sides of that number? Okay, now I ask myself this question. Which perfect square is 51 closest to? 49, it's only 2 away, right? Well, 64, it's 13 away. So, based on the fact that 51 is closer to 49, I would say that the square root of 51 is approximately 7. Where did I get 7 from?
49.
Because that's the square root of 49. And I'm like, okay, well, if square root of 49 is 7, square root of 51 is going to be pretty close to 7, isn't it? No, you don't. And why don't you need the positive and negative symbol? Because there is a radical in my original problem, and the radical is positive. If it's negative, it'll be in the original problem. So when the radical is there, my answer is only going to be either positive or negative. All right? I want you to try the next one. Try the next two if you think you can do it. But try the next one, and then we're going to go over it. All right, so what perfect square would be lower than 93?
81.
Very good. So square root of 93, square root of 81 is on this side. It's less than, and what would be on the high end?
100.
100. Very good. And which one is it closest to?
100.
It's closest to 100, right? Because it's only 7 away from 100. And it's 12 away from 81. So I would say that the square root of 93 is approximately 10. Very good. Anybody get that right before I said it? Okay, good. All right, I want you to try the last one now. Okay, so find the perfect square on the low end, lower than 24, and the perfect square above 24, whichever one it's closest to, that's what we're going to approximate our answer to. Okay, so on the low end, it's going to be square root of 16, square root of 24, square root of 25. Wow, that's like a no-brainer, right? 24 is only 1 less than 25. So I would say that the square root of 24 is approximately what? 5. All right, who got that one right? More? Okay, good. Good. All right, so that's it for example 2. Believe it or not, I think example 3 might be easier than example 2. You happy about that? Okay, so let's look at it. Now it says use your favorite thing in the world. What is that? A calculator. So put it in your calculator. What is the square root of 515 rounded to the nearest tenth? You just put it in your calculator and then you change to a decimal. So it's going to be, now remember, we have to approximate it. We got to do our squigglies to 22 and 7/10. Okay, did you get that on your calculators? Do you see how we did that? Because it was 22.69, so the 9 rounds a 6 up to a 7. Okay, and this is your work. I want to see that you show the approximation symbol. You can box the whole thing. That would be fine. All right, but at least your answer. All right, I want you to try the next two. Use a calculator to approximate those square roots. And why is my answer only positive? Because of the radical sign. Look at number 2 for a second. What if there was one of these out in front of it? What would my answer be? It would just be negative, okay? So the radical is positive unless there's a negative sign in front of it. Then it's going to be, your answer will be negative. All right, square root of 234 is approximately what?
15.3.
Do you agree? Okay, square root of 234 is approximately 15, and we say 3/10. 15 and 3/10. Now, square root of 472 is approximately, I just hear a bunch of mumbling. What is it? All right, 21 and 7/10. Very good. All right, who got those right? Good, awesome. Okay, moving on to example 4, radical expressions. Does anybody remember what an expression is? What is an expression? A number, a variable, and an operation. And then we know the radical is just a square root symbol, right? Okay, so radical expressions, it's going to be an expression underneath a radical sign. It's going to look like this. So now it says evaluate 2 times the square root of a plus b squared when a is 11 and b is 5. So the first thing we're going to do is we're going to substitute our value for our variable. 2 times the square root of 11 plus 5 squared. That's kind of messy. Okay. And now I'm going to follow my order of operations. So underneath the radical, what do you think you're going to evaluate first? 5 squared. You're not going to say 11 plus 5 is 16 and then square it. That's not order of operations. So 5 squared is what? 25, and 25 plus 11 is 36. Can you do that mental math? Okay, if you're having trouble with that, you can write out that step, but I don't mind if you just go ahead and skip to 2 times the square root of 36. Okay, now, can I find the square root of 36? Yeah, what is it? 6. So 2 times 6 is 12. And that's going to be my answer. So it's just a step-by-step process. Here's my advice to you. I'm not going to be super picky on you showing every single little step. But here's what I would say. The more you write out, the less of a chance that you have of making a mistake. The more you try to do in your head, those numbers start blending together. Okay? So I do have to see at least the substitution. Okay, you've got to substitute it. You need to show me how you're evaluating along the way. You just don't have to show every single little step. All right, go ahead and try number 2 on your own. All right, first things first, substitution. 5 times the square root of 7 plus 3 squared. So what do we do first?
Change it to 16.
Okay, yes, change it to 16 because 3 squared is 9 and 9 plus 7 is 16. So 5 times the square root of 16. And what is the square root of 16?
4.
So 5 times 4 is 20. Who got 20? All right, very good. Okay, just a couple more minutes and to finish number 3. These numbers are a little bigger, okay, but you can use your calculator. So, all right, so 7 times the square root of 23 plus 11 squared. Well, what's 11 squared? Okay, 121 plus 23. 144, so 7 times the square root of 144, okay, which we know is what? 12, so 7 times 12 is 84. All right, who got 84? Awesome. One more example, okay? Now, in example 5, we're going to start, I don't want to start with a word problem because this is not how you're going to see it on your homework tonight. And honestly, it's not how you're going to see it on a quiz or a test either. You might have a word problem, but this is the more common way that we would look at it. Let's say that we're going to start simple. A squared, oh, that looks like a 9. A squared equals 9. All right, this is an equation. I'm solving an equation. Well, you've been solving equations for months. And the key is to do the opposite operation, right? So if multiplication, if it's, let's say it's 2x equals 18, what are you going to do to solve for x? Divide both sides by 2, because multiplication is connected to my variable. Well, here, what's connected to your variable? An exponent, okay? And more specifically, a square. So what is the opposite of squaring a number? It is taking the square root. And whatever you do to one side, you have to do to the other side. Now, here's the trick, okay? When you're solving equations, you will have a positive and a negative solution. And I'll show you why. Okay? So here's what you show, guys. You write your original problem, and now you show how you're taking the square root of both sides. When you take the square root of something that's squared, it essentially cancels it out, so I have a by itself now equals, and what is the square root of 9?
3.
It is 3. But your answer when you're solving an equation is going to be positive and negative. Why? Because when I plug it back in, what's negative 3 times negative 3?
9.
It's still 9, okay? So the negative part of the solution still works out. A equals positive and negative 3. All right, now I want you to do this one. What about n squared equals 25? Go ahead and solve that one. All right, again, since I have an exponent of 2 that's connected to my variable, how do I get rid of it? I take the square root. So show how you're taking the square root of both sides. N equals positive and negative 5. Don't forget the positive negative. Why? Because when I plug it back in to check it, negative 5 times negative 5 is still positive 25. Do you see that? So both solutions work out. That's why it's positive and negative. It'll get more complicated. What if I said, I'm going to give you one that's a little more complicated, and then we'll move on to two-step. All right, go ahead and solve for y on this one. All right, what do you do to both sides? Take the square root. So y equals what? Positive and negative 20. What about this one? What if I said, let me see. What if I said 20 equals m squared? Is 20, can I take the square root of 20? Is it going to be even? No, and that's okay. If it's not, now if it doesn't work out to be an exact answer, the directions will say round to the nearest tenth. So I want you to go ahead and just round this answer to the nearest tenth. All right, same process. Take the square root on both sides. What's the square root of 20? Round it to the nearest tenth. 4.5, 4 and 5/10. So you can say it either way. Positive, negative, 4.5 equals m. Or could you say m equals positive, negative 4.5? It's the same thing. Now, I think in my mind, I like saying the variable first, but it doesn't matter either way. All right, so it's okay if it doesn't work out to be an even number. In your homework tonight, some of these don't work out evenly. So these are all one-step equations. But what if I had an equation like 5y squared equals 110? Now I have a number attached to my variable. Ugh. So what do I have to do first? Divide both sides by 5. Okay, so now y squared equals, what's 110 divided by 5? 22. Well, that's still not going to come out evenly, but that's okay. Now what's my next step? Take the square root of both sides. I should have written this underneath. Oh well, it's fine. Y equals positive and negative,
4.7.
rounded to the nearest tenth, 4.7. Think you can do one?
Yes.
Yeah, of course you can. Of course they're going to get harder. All right. 0.5 t squared equals 162. Go ahead and solve this one. Okay, what do I do first? What do I do first? Divide both sides by 0.5. Okay, and now I have t squared equals 162 divided by 0.5, which is 324.
Wait, no, I did it right.
Okay, now what do I do? Square root. T equals positive and negative 18. Who got 18? Awesome. Good job. Good job.
But I just kept going.
All right, last one and we're done. Okay. 2a squared plus 1 equals 98. 2a squared plus 1 equals 98. Solve for a. All right, what do I do first? Subtract 1. 2a squared equals 97. What do I do now? Divide both sides by 2. A squared equals 48 and a half.
Yes.
All right, now what do I do? This is definitely not going to be even, right? Okay, so A is approximately square root, guys, quiet. Square root of, oh yeah, it's going to be 7 because it's 6 point, well, I did say round to the nearest 100. So, but if you said 7, that's okay. It's going to be 6.96. Now, on your homework tonight, the directions are very specific. It'll say round to the nearest 10th or round to the nearest 100. Just follow the directions and you'll be fine. All right, if you understand that, that's everything you need to know for 9.1.